Hello, I'm presenting a paper titled Task Adaptive LLMs to Generate Human-Persuasive Investment Reports that aims to address the challenge posed by this FinNLP shared task. We address this challenge with a two-stage framework system to generate human-persuasive reports. Previous studies on evaluation have demonstrated limitations of automatic evaluation in financial text generation. We break down the objectives of this task into several unique challenges, such as generated reports must be both analytically and psychologically sound to be persuasive. Reports must contain necessary information to provide correct and actionable guidance. Success of the reports depends on understanding various investor profiles. Absence of ground truth poses a fundamental challenge to evaluate and optimize the behavior of LLMs. To address these challenges, we propose a task adaptive framework where an LLM first acts as a data extractor and then as a cognitive reasoner. The model first acts as a data extractor to extract key implicit and explicit information from the transcripts by carefully analyzing the prepared remarks and each question-answer QA pair. Then, the model transitions its role to a cognitive reasoner to perform flexible reasoning, leveraging its sophisticated inference capabilities for multi-perspective synthesis. The dual-mode architecture we employ balances precision with creativity. Extraction tasks require high accuracy, and persuasive report generation demands flexible reasoning with psychological insight. By optimizing each stage for specific tasks, our framework achieves both analytical precision and human persuasiveness. To derive explicit and implicit information from the call transcripts, we first employed an enhanced investment-centric sentiment analysis and information extraction process. For each QA pair within the call transcript, the model that acts as a data extractor identifies the most suitable sentiment out of 8 possible defined categories. It then evaluates the confidence within the sentiment and identifies all key phrases that contributed to the sentiment classification for that QA pair. The model also identifies the tone of the speaker. Is it avoidance or is it dodging? And provides a score with an interpretation. Finally, the model provides the interpretation on the investment signal for each exchange, which is crucial for the next stage in the framework. The second stage focuses on personality and analysis-driven investment report generation. The summary created in the previous stage and several different types of personalities, along with the descriptions, are fed as input to the model, which in this stage acts as a cognitive reasoner to generate reports. Because in the real-world scenario, there can be several different personalities, we do not limit the large language model to the list of investor profiles, but instead allow it to identify the similarities and differences across these profiles when generating recommendations and evidences for decision making. We prompt the cognitive reasoner model to analyze how different personality types would interpret the same information, common traits that tie suitable investors together, identification of investor types beyond angel, venture, personal, institutional, and crowdfunding that would be best suited for the investment, and balanced reasoning that synthesizes multiple viewpoints. We also employ a comprehensive and sophisticated 6-dimensional analysis framework covering financial performance, business fundamentals, including environmental, social, and governance considerations, risk assessment, forward outlook, and personal factors. Additionally, the framework generates conviction scoring with percentages for clear interpretation that quantify uncertainty. Reports provide recommendations for 1 day, 1 week, and 1 month, recognizing that short-term price movements substantially differ from long-term performance drivers. Throughout this process, the framework ensures error avoidance by identifying common analytical errors such as optimum bias, making recommendations without considering investor suitability, and strictly adhering to the framework, ensuring the generated reports maintain analytical rigor, correctness, that's no hallucinations, and practical applicability with persuasion for human decision making. Our framework leverages GPT-4o with a temperature of 0.5, max tokens of 4096, and TOPI parameter as 0.95 for both the models. Our results demonstrate the success of the approach using human and automated Likert score. While there is still scope of improvement on accuracy of the model-generated reports on the leaderboard, we rank first out of 12 teams in the human average Likert score, fourth for the one-day time frame in the human average accuracy, second in the automated average Likert score, and fourth in the win rate versus analyst report metrics. To conclude, we present a task-adaptive LLM framework that addresses the fundamental challenge of generating investment reports optimized for human decision-making, as posed by the FinNLP Earnings to Insights shared task. Our key contribution lies in the dual-mode cognitive architecture, where in the first stage the model acts as a data extractor using 8 sophisticated sentiments, and in the second stage acts as a cognitive reasoner using investor personality modeling and our 6D analysis framework. Thank you.